Hi guys, IBM is my name and I welcome you to my YouTube channel. And do not forget to subscribe, share the documents in the video description, download them, print, follow the videos with a printed copy of the documents so you'll become confident with physics. So this is Learning Physics with IBM, and without wasting time, I would like to take you to what we are actually dealing with today. Remember, I'm trying to solve past paper questions of AS Physics, multiple choice questions, Physics 9702. Remember, this is kinematics and dynamics, and this is going to be part 6. So without wasting time, I would like to take you to the document so that we solve the questions. So in part 5, I think we stopped on page 44, and in part 6, I want us to start from page 45. A student cycles uphill from home to a shop, taking 10 minutes. The student then spends 5 minutes in the shop. So here he's at rest. Before cycling home downhill at twice the speed, so here the gradient should be twice. Gradient twice, 2 times. Which graph could show the variation with the time of the distance traveled by the cyclist? Okay, so the student cycles uphill from home to a shop, taking 10 minutes. The student then spends 5 minutes in the shop. So after 10 minutes, it must be constant. It must be at a constant distance. So this one is wrong. The distance is constant after 5 minutes, so that is wrong. It means C is also wrong because the distance is constant after 5 minutes. Then we have to look at B and D. So for B and D, the distance is remaining constant after 10 minutes, which is fine. It remains in the shop for 5 minutes, so the distance remains constant for another 5 minutes, which is also fine for both the graphs. But then the student then spends 5 minutes in the shop. There the distance remains constant. Before cycling home down at twice the speed, so it means is cycling home, that means the distance should decrease. Is cycling home at twice, because this is distance, it is a scalar quantity, we don't mind about the direction, so the direction can remain the same. So which graph could show the variation with time of distance traveled by the cyclist? So here the answer is going to be, let's compare the gradients. So this one is a positive gradient, this is also a positive gradient. And then this one here, compare this gradient here with the first one. So the gradient here is going to be 1 divided by 5. Let's compare this gradient here. So here the gradient is going to be 2 minus 1, which is 1, divided by 20 minus 5, which is 5. But they said the student then spends 5 minutes in the shop before cycling home down at that is at the time at twice the initial speed. So comparing this first part, the time it took 10 minutes to cover a distance of 1 kilometer, and after it's taking 5 minutes to cover again a distance of 1 kilometer. So the answer here is going to be D. Why not B? Distance is a scalar quantity, so it just continues adding up. If you take B, you have considered distance as a vector quantity, so the answer is going to be D because distance is scalar. When you add up scalar quantities, the magnitude becomes bigger. So the total distance must become 2 meters, yet in B, total distance will be 0 because it goes back is going back home. Yet that would mean you are considering distance as a vector quantity. So if it was displacement, the answer would be B, but since it is distance, the answer is going to be D. Two cars X and Y are traveling along the same straight road. Car X is traveling at a constant speed of 6 meters per second. Car Y has a constant acceleration of 0.5 meters per second. At the instant shown, car X is a distance d ahead of car Y. Car Y is traveling at a speed of 4 meters per second. Car Y is level with car X after a time of 20 seconds. So it means they have traveled the same time. By the time they are level, they have traveled the same time. What is the distance d? So to begin with, X is traveling at a constant speed. So the distance in 20 seconds for X is going to be simply 20 times 6, which is 120 meters. That's the distance it has covered in 20 seconds. Then for y, since it is having an acceleration, I'll use equations of motion. S for y is going to be initial velocity times t plus a half at squared. So S for y is going to be initial velocity. Y has a constant acceleration and its initial velocity is at equals to 0 was 4 seconds. So this is going to be 4 times the time, which is 20, plus a half times acceleration, which is 0.5, then times time, which is 20, but this is squared. So I'll check this with my calculator. 20 times that is 80 plus 0.5 times 0.5 times 20 squared. So this gives me SY as 180 after 20 seconds. So what is the distance D? So what distance are they apart after 20 seconds? So the distance D is going to be 180 minus 120, which is equal to 60 meters. So the answer is going to be B. The graph shows how quantity P varies with quantity Q for an object falling in air for a long time T in a uniform gravitational field. What could be the identities of P and Q? Let's do inspection. Call this inspection. A, force of air resistance and acceleration. I think this is not going to be correct. Why? Because as the object is falling, the speed is going to be increasing. That means as the force to air resistance increases, because it increases with the speed, the acceleration must be decreasing. So this makes A to be wrong, because we don't see acceleration decreasing when the force increases. So that is wrong. Then B, kinetic energy against time. This is also going to be wrong. Remember, it is a straight line, which means kinetic energy is directly proportional to time, which means the V, velocity squared, should be directly proportional to time. So if this was kinetic energy with time, remember V becomes constant with time. So when acceleration becomes 0, V is constant. Since there is air resistance, there is going to reach a point where, if there is air resistance, there is going to reach a point where the velocity becomes constant. That means kinetic energy should become constant with time. So this means EK should become a constant with time. And we don't see that from the graph, so that is wrong. C, potential energy against height. We know that potential energy is equal to mgh. If P is potential energy and Q is h, P is going to be directly proportional to Q, which is a straight line. So the answer is going to be C. If P is potential energy and Q is height, as height increases, potential energy increases, that is a straight line. So the answer is going to be C. Why can't it be? So this is for C. This was explaining B. This was explaining why not A. Then why not D? D will also be wrong, because work done is equal to force times distance. And we are looking at work done against air resistance. Remember, the force due to air resistance is directly proportional to V squared. So it means it also means the work done will be the force due to air resistance times D, and force due to air resistance is directly proportional to V squared. As speed increases, the force will be directly proportional to the square of the speed. So this cannot be a straight line, but it will be a quadratic. It will be quadratic. It will be quadratic. Yet here we have a straight line, which is a equation of a line. So this one is also not correct, because if we were to take this work done against speed, then it would mean the work done would be directly proportional to the square of the speed, which would be quadratic rather than a straight line. So the answer is C. A rope R of mass 1.0 times 10 power 27 kilograms is a large distance from a star S and is traveling at a speed of 1 times 10 power 4 meters per second. The star has mass 1 times 10 power 30 kilograms. The rock travels around the star on the path shown so that it reverses its direction of motion. And when finally again a large distance from the star has the same speed as initially. Okay, which statement is correct? Which statement is correct? Number one, the change in the momentum of S is in the direction of Rx. The change in momentum of X, the change in momentum of S is in the direction of Rx. I don't think this is true, because if you look at Newton's third law, then this will be, by Newton's third law, that will not be correct. The change in momentum of S cannot be in the direction of the Rx. Let's check the change in the velocity of S is approximately 20 meters per second. Let's test that one. The change in momentum of R should be equal to the change in momentum of S according to the law of conservation of momentum. The change in momentum of R is going to be 1 times 10 power 27 times its speed, which is 1 times 10 power 4, should be equal to the change in momentum. Oh, sorry. Total change in momentum. So this is going to be equal to the change in momentum of R should be equal to the change in momentum of S. Okay, so this is the initial momentum. So I'm going to say minus negative for R. So its new momentum is in the opposite direction, so it's minus negative 1 times 10 power 27 times its speed, which is 10 power 4. That is the change in momentum for R. So this is minus negative. So this should be called the change in momentum for S. Then for S, its mass is 1 times 10 power 30, then times its velocity change, its change in velocity. We don't know its change in velocity. Let me just say delta V. So change in velocity of S. Okay. So when we this is going to be addition, so that is going to be plus, and I think that gives us what is this value, plus? So this is going to be 2 times 10 power, I think times 10 power 27 plus 4, that is 31, is equal to 1 times 10 power 30 times the change in velocity for S. So the change in velocity for S is going to be 2 times 10 power 1, which is equal to 20 meters per second. So the change in the velocity of S is approximately 20 meters per second. So the answer is going to be B automatically. We can't have more than one correct answer. The diagram shows the masses and the velocities of two trolleys that are about to collide. After the impact, they move off together, so they stick together. What is the kinetic energy lost in the collision? So let's first conserve momentum. Momentum is mass times velocity. Total momentum before, velocity is to the right, positive, to the left, negative. So total momentum before is going to be 4 times the speed, which is 2. Mass, which is 2 times the speed, which is 4, plus the other one, mass is 4 times the speed, which is 1, should be equal to total momentum after. Since they stick together, their total mass is 2 plus 4 plus 2, which is 6, times their common velocity v. So 8 plus 4, 12 divided by 6, that is giving us 2. So v is going to be 2 meters per second. That is their common velocity. Then change in energy, the change in kinetic energy. Initial kinetic energy is going to be a half times the mass of the first one, which is 2 times 4 squared plus a half. The mass of the second one is 4. Its speed is 1 squared. That is total kinetic energy before minus kinetic energy after is a half. Total mass is 6. Total common velocity is 2 squared. So this is 16 plus 2, which is 18, minus 3 times 4, which is 12. That gives us 6 joules. So the answer is going to be B. A stone is thrown vertically upwards from a point X at time t equals to 0. The variation with the time t of the velocity v of the stone is shown. What is the displacement of the stone from point X at time t equals to 0? Displacement. So here it is going upwards. Here it is at maximum displacement, where v is 0, it is at maximum height. This is maximum height. Then here it is now moving in the opposite direction. So we are just going to subtract. So the distance, the displacement S is going to be the distance upwards, which is a half. Area of a triangle, a half times 2 times 20. That is the distance upwards, minus the distance down, which is a half, times 3 minus 2, which is 1, times 10. So this is 20 minus 10, minus 5, which is equal to 15. But here it was going upwards, here it is going downwards, so it is still above the point of projection. So the answer is 15 meters, but it is above X. So if it is, this is the point X, it is projected upwards and it comes back. So this is going upwards is 20, and it has fallen downwards 5 meters. So it is still this distance here above X, which is 15 meters. So it is 15 meters above the point of projection X. If this is the X. A mass of 5 kilograms is released from rest on a frictionless surface inclined at 30 degrees to the horizontal. Air resistance is negligible, so acceleration is acceleration due to gravity, which is constant. How far does the mass travel in a time of 0.8 seconds? So let's first find the acceleration. By Newton's second law, the resultant force is equal to mass times acceleration. Since the only force acting on this mass is the component of the weight down the slope, because it is frictionless, so the component down the slope is going to be mg sine theta. We resolve mg parallel to the plane. So this is going to be mg sine of theta. So it means the acceleration of the mass is g, because m cancels. So it is 9.81 sine of 30. That is the acceleration. Then how far? So that is distance. So I would say s is equal to ut plus a half 80 squared. So it starts from rest, so initial velocity is 0, so it will be a half times acceleration, which is 9.81 sine of 30, then times t squared. The time is 0.8 squared. So I'll press my calculator. 0.5 for a half times 9.81 sine of 30, then times 0.8 squared. So that is 1.6 meters. So the answer is going to be A. What is not a statement of one of Newton's laws of motion? If body X exerts a force on body Y exerts an equal but an opposite force on body X. That is Newton's first law. No, that is Newton's third law. If no resultant force acts on a body, it has a constant velocity. This is Newton's first law. As long as there is no resultant force on a body, it remains with a constant velocity. The rate of change of momentum of a body is proportional to the resultant force acting on it and takes place in the direction of the force. This is Newton's second law. So it means the answer is going to be D. What is not a statement? Total momentum of a system of interacting bodies is constant if there is no external force. That is not Newton's laws. An object falls from a tall building. The graph shows how the velocity of the object changes with time. So we see that the gradient decreases to reach its terminal velocity. The acceleration of free fall is g. What describes the acceleration of the object at times t equals to y? There it is decreasing, t equals to z, it is 0. So t equals to z, the acceleration must be 0 because the gradient is decreasing. So acceleration equals to the gradient. The velocity is becoming constant, meaning acceleration here is 0 because acceleration is the gradient. A constant velocity means 0 acceleration. Then here the gradient is decreasing, so it means here acceleration is decreasing. So acceleration is decreasing at y and 0 at z. So the answer is going to be B. Two balls, one of mass 2m and one of mass m, collide. The diagram shows the initial and final velocities of the balls, which collision is not elastic. So we just check the relative speeds of approach and relative speeds of separation. For elastic, relative speed of approach should be equal to relative speed of separation. So here, relative speed of approach, velocities to all velocities are on the same side, so velocity we just subtract them, highest minus lowest. So this is going to be 3 difference, and here it is 3. So that one is fine, it is elastic. Here it is 6 minus 3, which is 3. Here it is 7 minus 4, which is 3. That is elastic. Here relative velocity is 8 minus 2, which is 5. 6, relative velocity of approach. Relative velocity of separation is 8 minus 5, which is 2. So they are not the same. This is not elastic. Here relative velocity is 10 minus 4, which is 6. Relative velocity is 12 minus 6, which is 6. This is elastic. So the answer is C. C is not elastic. The diagram shows a ballistic pendulum. A pellet of mass m traveling at speed u hits a stationary block of mass m. The pellet becomes embedded in the block and causes the block to move at a speed v immediately after impact. Immediately after impact, when a pellet of mass 2m traveling at a speed 2u hits a block of mass 2m, what is the speed of the block immediately after the impact? Neglect the small increase in the mass of the block as the pellet's mass is added during the collision. Okay, so we're just going to use our conservation of momentum first. Initially, the only thing having momentum is the pellet. So its total momentum before collision is m, mass of the pellet, times its speed. But since they stick together after collision, total momentum becomes small m plus capital M. Then they will move with a common velocity, let me call it v. So it means v is going to be equal to m divided by small m plus capital M. Then times u. That is the velocity after collision. Then when a pellet of mass 2m traveling with speed that hits the block of mass 2m, what is the speed of the block immediately after impact? So let's look at the one of mass 2m. Initially, it is the one moving. Its total momentum is going to be 2m times 2u. Its speed is 2u. The other one is initial at rest, so it is plus 0. Then after collision, if they stick together, the total mass becomes 2 small m plus 2 capital M. Then times, let the velocity here be Vx. So we have that 4mu is going to be equal to 2 into small m plus capital M times Vx. So making Vx the subject, Vx is going to be equal to twice. Of course, we divide, it becomes 2, so it becomes 2 mu divided by m plus capital M. And this is the same as m over small m plus capital M times u, then times 2. So this one was the velocity v before. So it means Vx is going to be twice of the v we got earlier on. So the answer is going to be C. An object in a straight line moves in a straight line. The graph shows the variation of the time t of the velocity v of the object. At time t equals 0, the object is at point x. At t equals 0, the object is at point x. What is the displacement of the object from point x at time t equal to 0.8? So 0.8 is here. And so at point, if it first moves in one direction, then changes direction. So we want the displacement, so we shall just subtract. So the displacement in one direction is going to be area under the graph. So that is a half times, this is 6 minus 0, which is 6, times, I'm finding the area of this triangle here first. Then 0.8 minus 0.2, which is 0.6. That is the area, distance in one direction, minus distance in the other direction, which will be a half, times 0. I'm looking at now this area here. So that is times 0.2, then times 2. So this is going to be, I think this is 1.8 minus, the other one is going to be 0.2, which gives us 1.6. So this should be 1.6. The answer is A. An object accelerates uniformly from rest to speed v. It then moves at a constant speed v for a time of 8 seconds. I will sketch this for easy understanding. So I'm sketching a graph of velocity with time. So it first accelerates uniformly from rest to speed v. So this is to a speed v. It then moves at constant velocity. So it moves at a constant velocity v for a time of 8 seconds. So let this be t. Then this is going to be 8 seconds. Before decelerating uniformly to rest. So it decelerates, the velocity decreases to rest. Total time is 12 seconds. So here it reaches here in 12 seconds. So this is 0 to t. Then this will be t plus 8. Total time is 12 seconds. So that is the graph of velocity against time. What is the speed v? Okay. So let's first find the total distance is 60 meters. How do we find total distance? Total distance is the area. Total distance is going to be equal to the area under that graph. And this is going to be equal to, so total distance, remember, is 60. So we shall say that 60 equals to the area for the first part is a triangle, which is a half, times v times the time t, plus the second part is a rectangle, which is 8 on the x-axis against v, so it is 8v, plus the last part is a triangle, which is a half times v, a half times v, half times v, so we can, this time is t and this time is t plus 8, so this time is going to be 12 minus t plus 8. Let me see, 12 minus t plus 8, it becomes 4 minus t. So that time is 4 minus, this time is going to be 4 minus t. So this is going to be v into 4 minus t. Okay. So if I open the bracket, of course you have 60 equals to a half vt plus 8v plus a half. This becomes a half times v times 4, it becomes 2v. This will be 2v. So it will be plus 2v, then a half v times t, that is minus a half vt, where this one and this one cancels. So remain with 10v. So v is equal to 6 meters per second. So the answer is going to be C. A device for spraying paint consists of a box with its axis horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. So paint is coming out horizontally, paint out through holes. Only a few holes are shown. The paint is ejected at a speed of 2.5 meters per second through 400 holes. Okay. Each of area 0.4 millimeters squared. The density of the paint is 900 kilograms per meters cubed. What is the horizontal force required to hold the device stationary as it ejects the paint? Of course, as the paint comes out by Newton's third law, the force the force propelling, or the action by the paint coming out of the hole should be equal to the reaction, so that if the devices remain stationary. So remember, we know that force is the rate of change of momentum, and this is going to be mass over time times difference in velocity, or mass times change in velocity over t. Or just simply, since they start from rest, I'll just simply say m times v. Of course, our change in velocity is going to be v minus u, but this is v minus 0, so it is just mv over time t. Also recall that mass is equal to density times volume, and this is going to be density times cross-sectional area times another length, that is the volume. And the distance through which they move, which is the length L, since if they are moving, if they are ejected at a constant speed, then L, or the distance through which they move, is going to be v times t. So it means the force is going to be equal to the mass, which mass is density times cross-sectional area, where there is L, I'm putting there v times t, then times, I substitute this one into that equation for m, and I substitute for L with vt. Then so I remain with times v over t times v divided by t. So one t cancels out, and v becomes squared. So it means the force is going to be density times cross-sectional area times v squared, which is going to be, the density is 900 times the cross-sectional area, which is 0.4. We change it to meters squared, so it is going to be 0.4 times 10 power minus 6. We multiply this by 10 power minus 6 to change it to meters squared. Then times v, which is the speed squared, which is going to be 2.5, and this is squared. So we have 900 times 0.4 exponent minus 6 times 2.5 squared. 900 times 0.4 exponent minus 6 times 2.5 squared. So I'm getting Okay, let me repeat this again. 2.5 squared times, oh, there are 400 holes. So that is just for one, okay? So I'll multiply this by 400. So 900 times 0.4 exponent minus 6 times 2.5 squared times 400, which gives us 0.9. So this is 0.9 newtons. So the answer is going to be B. I multiplied by 400 because there are 400 holes. For each, or for just one hole, that is the force. But for 400 holes, I multiply this by 400. So it becomes times 400. And that means I want to remove this line. Okay. A portable balloon is filled with air and held stationary at a height of several meters above the ground. The balloon is then dropped in still air. Which statement describes the motion of the balloon from the moment of release until just before it hits the floor? It is dropped in still air. So of course we know that as speed increases, air resistance also increases. That means a point is going to reach where the speed becomes constant. So force due to air increases as V increases. As V increases, eventually resultant force F resultant will become 0, which means the acceleration will become 0, so V becomes constant. When V becomes constant, we have reached terminal velocity. So the ball initially accelerates. Yes, it accelerates, but the acceleration decreases. And then reaches a constant speed. So it must reach a constant speed. The ball falls at a constant speed, not at all. Speed first increases before it becomes constant. The ball decelerates continuously, speed first increases. The ball falls at constant speed, then decelerates. The speed first increases because there is an acceleration until the resultant force becomes 0. That's when the speed becomes constant. So the answer is going to be D. An object of mass m traveling with speed 5u collides with and sticks to an object of mass 5m traveling the same direction with speed u. What is the speed with which the two objects travel in the opposite direction? Okay. So by conservation of momentum, remember momentum is mass times velocity. So total momentum before is going to be m times 5m plus, for the other one is 5m, sorry, this is 5u, not 5m. So it is m times 5u, then plus 5m times u, that's total momentum before. Then this should be equal to total momentum after they stick together. The total mass is 6m. Then let their speed be v after collision. So we have 5 plus 5, that is 10 m u is equal to 6 m v. M cancels out. So v is going to be 10 over 6 times u. 10 over 6 times u. So the question is, what is the speed with which the two objects travel together in the original direction? So it is 10 over 6u. So the answer is D. An air bubble is raising through a liquid at constant speed. The forces on it are the upthrust, the viscous drag, and its weight. We answer this question: force, density, and pressure. Which diagram shows the directions and relative sizes of the forces? So since it is moving with a constant speed, acceleration is equal to 0, the resultant force should be 0. Remember, the weight should be equal to the upthrust plus the viscous drag. An air bubble is raising through a liquid at constant speed. So the weight is downwards. The viscous drag must be downwards. So let me add the viscous drag downwards. So the weight plus, because it is raising, the viscous drag is like friction, so it must be in the opposite direction. So the weight plus the viscous drag must be called the upthrust. So it means to find the weight, we get the upthrust minus the viscous drag. So it means the viscous drag, they're using V for viscous drag. Let me use V for viscous drag. So it means the viscous drag must be the smallest. So it means, no, not the viscous drag. To get the weight is the upthrust minus the viscous drag. So most likely the weight is going to be the smallest, but let's begin by eliminating those which do not add up to give us the force in the opposite direction. So number one, since it is raising, the viscous drag must be downward. So D is out. Viscous drag is in the opposite direction. It is downwards. Then let's try to add them to scale. If I measure these lengths, even without measuring, when I add this length here to this one, I don't get the other one in the opposite direction. So this is out. Then I can check these ones. C. I will check C. First of all, by measuring the lengths. But since it is an air bubble, so this is going to be wrong. The answer is going to be A. Because if it is an air bubble, for an air bubble, the weight is much less than the viscous drag. For an air bubble, the weight is less than the viscous drag. I don't even need to measure these ones. So the answer is going to be A. So for an air bubble, the weight should be less than the viscous drag because the air bubble is very light. So it means the viscous drag will be greater than the weight. So the answer is going to be A. A stone of mass m is dropped from a tall building. There is significant air resistance. The acceleration of free fall is g. When the stone is falling at constant terminal velocity, which information is correct? So here acceleration has become 0 at constant velocity. The magnitude of the acceleration goes to 0, so A is out. Then the magnitude of the force of gravity on the stone, so the weight, of course, the weight remains constant. The weight remains constant even though when it is falling at terminal velocity, the resultant force is equal to 0, which means that the weight is equal to the force due to air resistance. The magnitude of the force of air resistance of the stone is equal to weight. So the weight must be equal to the force due to air resistance when the resultant force is 0. So this one, D is out. So D is out. The weight remains constant. So C is also out. The weight remains mg. So the acceleration goes to 0. The weight remains mg. And the force due to air resistance will be equal to the weight. So the answer is going to be B. The velocity time graph for an object is shown. How can the total distance of the object be determined? We just get area 1, total displacement, area 1 minus area 2. So total displacement is the area under the graph. This is positive direction, this is opposite direction. So we shall get area 1 minus area 2 because of the difference in direction. Since displacement is a vector quantity, so the answer is going to be A. If it was distance, I would say area 1 plus. But since this displacement is area 1 minus because of opposite directions. So distance is equal to area under the graph. The object changes direction, so we subtract. A girl throws a ball vertically upwards. It takes a time of 3.20 seconds to return to her hand. Assume air resistance is negligible. What is the initial speed? What is the initial speed with which the ball is thrown? Okay. If air resistance is negligible, acceleration is going to be acceleration due to gravity. So I'll simply use S equals to ut plus a half at squared. Since it returns to her hand, the displacement is 0. It comes back to the same level. Displacement will be 0. Initial velocity, let it be u. It takes time of 3.2 seconds, so times 3.2. It moves against gravity initially, so this will become, acceleration is going to be negative g. So we shall have minus a half times 9.81, then times 3.2 squared. So this is going to give us, I'm taking one quantity the other side, 0.5 times 9.81, then times 3.2 squared on one side, then divide by 3.2. So this is giving me 15.7 for u. I made u the subject on one side, so u is going to be 15.7 meters per second. So the answer is going to be C. Steel pellets, each with mass 0.6 grams, fall vertically onto a horizontal plate at a rate of 100 pellets per minute. 100 pellets per minute. They strike the pellet with a velocity of 5 meters per second and rebound. So rebounding meaning a change in direction with a velocity of 4 meters per second. What is the average force exerted on the plate by the pellet? So force is equal to the rate of change of momentum. So force is the rate of change of momentum, which is going to be mass times change in velocity divided by t. So each pellet has a mass of 0.6 and they are 100. So the total mass is going to be 0.6. I will multiply by 10 power minus 3 to change it to kilograms times 100 because they are 100 in 1 minute. So the time is 1 minute. I will change time to seconds, which is 60. Then the velocity. They strike with 5 and rebound with 4. So it is 5 minus negative 4 because of the rebound. So this is 5 minus negative 4. So it becomes plus. So I will press my calculator. 0.6 exponent minus 3 times 100 times 9 divided by 60. So that is 9 times 10 power minus 3 or 0.009. So the answer is C. A tennis ball falls freely in air with the top of from the top of a tall building. It is falling in air. Which graph best represents the variation with time of the distance s? So the speed will reach a point and becomes constant. So v tends to a constant value. And remember, v is going to be the gradient. The speed is going to be the gradient. So the line should become horizontal. The line should become, the gradient should become constant, not horizontal. So v is the gradient. So the gradient should become constant. So let's inspect. This one shows that the gradient becomes 0. So here v is 0. It is falling. The speed increases until it becomes constant. So v is out. The gradient decreases to 0. Yet the v increases to a constant value. So v increases to a constant value. So the curve must have an increasing gradient where it now becomes a straight line, which means the answer is going to be A. This part here, v is constant. This part here, v is increasing. Of course, C is wrong because C is showing v is increasing to infinity. The gradient is increasing indefinitely. So here v is turning to infinity. And then here the gradient is decreasing, so v is actually decreasing. So it is just continuing to decrease. yet should increase to a constant value. So the answer is going to be A. The graph shows the variation with the mass of the weight of an object of objects on a particular planet. What is the value of the acceleration of free fall on the planet? So of course I'll just find, we know that weight is equal to mg. So if I have a graph of weight against m, the gradient is g. So g is going to simply be 4 minus 0 divided by, I think this is 1, 2, 3, 4, 5. So this is 2.5. So divided by 2.5 minus 0. And I'm very sure this is, I think that is 1.6. 4 divided by 2.5. That is 1.6. So this could be close to the moon. So this is 1.6 meters per second squared. The momentum of a car of mass m increases from P1 to P2. What is the increase in the kinetic energy of the car? Okay, so we know that momentum is mass times velocity. So for P1, we shall say P1 is going to be the mass times V1, which means V1 is equal to P1 over m, and also it means that V2 is going to be P2 over m. So we want kinetic energy, which is a half mv squared. So then of course you and me know that kinetic energy is equal to a half mv squared. So the change in kinetic energy is going to be equal to, the final kinetic energy will be a half m into P2 over m squared minus the initial, which is a half m into P1 over m squared. So if we factor out the common factors here, this is going to be a half. M cancels, we shall have an m in the denominator. So we remain with the P2 squared minus P1 squared. So the answer here is automatically going to be A half 1 over 2 m into P2 minus P1 squared. So that is going to be the change in kinetic energy. Two spheres, each with mass m and traveling with speed v are moving towards each other. The spheres have head-on elastic collision. Elastic. The relative speed of approach should be equal to the relative speed of separation. Kinetic energy must be conserved. Which statement is correct? The spheres stick together on impact. That means kinetic energy is not conserved because the difference in speed after collision will be 0. That is out. Total kinetic energy after impact is mv squared. Since the collision is elastic, let's find initial kinetic energy. Initial kinetic energy is going to be a half m for the first one, v squared plus a half m v squared for the second one, which is just mv squared. If the collision is elastic, the total kinetic energy after collision should also be mv squared. So total kinetic energy after impact is mv squared. So the answer is B. If the collision is elastic, the initial kinetic energy should be the same as the final kinetic energy. The velocity of an object changes with time as shown. Which graph best shows the variation with time t of the displacement s of the object? So here, the body reaches, the velocity decreases to 0. Here it has reached maximum height. It has reached the highest displacement. Maximum height. Here it has changed direction because the velocity is increasing in the opposite direction. So it is going downwards. So here the answer is going to be A. The gradient decreases to 0. At this point, velocity is 0. Here it is maximum height. Velocity should be 0. When you throw an object upwards, at the highest point, velocity is 0. So this is at maximum height. Velocity should be 0. At the highest point, velocity is 0. So it means this is wrong. This is showing that the velocity decreases until it becomes, because the gradient is decreasing, to 0. So this is wrong. This shows that the velocity remains constant it remains constant, then all of a sudden again changes to another constant value in the opposite direction. So the answer is A. The gradient decreases because the velocity decreases as the object goes up. At the highest point, velocity is 0. Then the gradient is increasing, but this is a negative gradient, so the gradient is increasing in the opposite direction. So the answer is A. A skydiver falls vertically from a helicopter and reaches constant terminal velocity. Constant terminal velocity. The graph shows the variation of velocity with time. The variation with time, t of the speed, v of the skydiver. Which graph shows the variation with time of the distance? So remember, velocity is the gradient of a distance. Time graph is the velocity. So let's just inspect the gradient of these graphs to see which one gives the other one. Gradient of this, the gradient should be the velocity. So here it is showing an increasing gradient, and then the line becomes constant. The line becomes straight, which means V, but even before it is a straight line, so it means V is initially constant here, gradient is constant here, then gradient increases, so here V increases, and then here V is constant. When I put a star, it means constant. So here V is constant, V increases, again constant. So this one is out. V is increasing, and then it increases, then the increase reduces, the rate at which it increases reduces, it becomes constant. Then B, it is showing that V is initially constant because the gradient is constant. Then here it is showing that V is decreasing. Here we don't have a decreasing velocity value of V, so this is out. For this one, initially it is showing the curve is having an increasing gradient, so this is showing that V is increasing. Then here it is a straight line, which means V is constant. And I think the answer is going to be C. V is increasing because the gradient increases here. Here gradient increases. So V is increasing. Then here it is a straight line, the gradient is constant, so V remains constant. So the answer is C. D is automatically wrong because D is showing the gradient is decreasing, so this shows V is decreasing. So this is out. So the answer is C. A tennis ball of mass 55 grams is traveling horizontally with a speed of 30 meters per second. The ball makes contact with the wall before rebounding in the horizontal direction with a speed of 20 meters per second. The ball is in contact with the wall for a time of 5 times 10 power minus 3 seconds. What is the average force exerted on the wall by the ball? Average force exerted on the wall by the ball. Okay. So we know that force is the rate of change of momentum. So I will simply say force is the change in momentum with time, which is going to be mass times change in velocity over time. The ball has mass 55 times 10 power minus 3 to change it to kilograms. The ball is in contact 5, so divide by 5 times 10 power minus 3. The change in velocity, since there is rebounding, one velocity is positive, the other one should be negative. So this would be 30 minus negative 20. So we can check with our calculator. 55 exponent minus 3 divided by 5 exponent minus 3 times 30 plus 20, that is 50. So we have 550. So the answer is D. An elastic collision occurs between two bodies X and Y. The mass of body X is m and the mass of body Y is 4m. They have said it is elastic, so momentum must be conserved. Kinetic energy is also conserved. What is the kinetic energy of body Y after the collision? Okay. So let's conserve momentum first. By conservation of momentum, total momentum before collision. Remember, one was moving with the speed v, the other one was at rest. So an elastic collision occurs between two bodies X and Y. The mass of body X is m, the mass of body Y is 4m. Body X travels at speed v before the collision and speed 3v, 3v over 5 in the opposite direction after the collision. Body Y is stationary before. Okay. So total momentum is simply going to be for body X, which is going to be m times its velocity, which is v. Total momentum before collision. Total momentum after collision is going to be for X is going to be m. For X it is going to be m times 3v over 5, but is to velocity to the right positive, velocity to the left negative. So I will start with the positive. So it will be 4m times its velocity, which is not known. I'll call it v subscript x minus, because this is in the opposite direction, so it will be minus m times 3v over 5. So we simplify this. M has cancelled, so I have v plus 3v over 5 equaling to 4vx. I cancelled out m. So LCM 5v plus 3v, that is 5v plus 3v divided by 4. Okay, that is 8v over 5 is equal to 4vx. So vx is equal to, by 4, that is 2 over 5 times v. Okay, so what is the kinetic energy of body Y after the collision? So we have seen its speed is 2 over 5v. So its kinetic energy is going to be equal to a half times its mass, which is 4m, times its speed, which is 2v over 5, but this is squared. So this is going to be 4v squared over 10 over 25. So it is 4m times 4v squared divided by 2 times 25, which is going to be 16m v squared divided by 50. 16m v squared over 50, so the answer is C. Okay, so let that mark the end of part 6. That's the end of part 6. So part 7 will start from here. Let's start from here in part 7. So I hope you learned something from this video, and I wish you all the best. Bye bye.